Hello, I'm Jacob Carter. I'm going to be a senior at Louisiana State University. I will graduate with a double major in computer science and electrical engineering with a minor in math. This summer, I participated in the SURF program at the University of Florida. I worked in the Focus Lab alongside a graduate student named Brevin Tillman. I also worked under the supervision of Dr. Sanjeev Kapal, who runs the Focus Lab. The Focus Lab is an optical lab that works with cameras and computer vision for the most part. So seeing how we can utilize cameras to the fullest potential using both hardware and software. Computer vision is the idea of getting a computer to understand what it sees in front of it using software. It's used in a lot of different applications. The one that might first come to mind is autonomous vehicles. They use a lot of cameras on them, and they try to interpret what the camera is seeing to see if they see a person, things like that. When I began this summer, I helped write a autofocusing algorithm for one of Brevin's camera projects. It was pretty simple to do. All of the values were already published by the person who made this specific camera. It was just about taking them and making it automatic for whenever you wanted to zoom in or out. After I finished that project in about a week or two, I started to work on the project that would consume the rest of my summer, a CUDA accelerated filtering algorithm. So normally whenever you are using a computer program, what it will do is it'll do one thing and then the next thing and then the next thing as you're writing lines of code. But a parallelized algorithm will allow you to execute multiple lines or statements at once. And CUDA is very good at writing parallel programs because it allows you to program on a GPU. A GPU is a graphics processing unit, and it has thousands upon thousands of threads that are each able to run their own statements of code at the same time. There's already been an algorithm like this that has been implemented that I'm using kind of as a guide to follow, and that's NVIDIA's FastANN paper. But they didn't release the code, and an algorithm like this would be useful in thousands of different applications and would be very useful for a lot of different projects. So that's why I tried to implement it on my own. I've had a lot of fun this summer. I've made a lot of friends, and I've learned a lot about what it's like to be in the PhD program here at UF. I want to say thank you to the University of Florida for allowing me to be here. And the Focus Lab for allowing me to work with them. I felt very at home with them and really appreciated the opportunities that I was given working in that lab. I also want to give a very special thanks to Brevin Tillman, my graduate mentor. He really believed in me, and he really pushed me to do things that were challenging, and I really, really appreciate that, and will continue to work on this project as I go back to LSU, and hopefully maybe get a paper out of it and get something for UF to show. I also want to thank Dr. Sanjeev Kapal for allowing me to continue my research. He's been an amazing person to work alongside, and I can tell that he appreciates me and the value that I provide to the lab. I'm planning on pursuing a PhD as of this moment. Hopefully UF is one of the places that I will be allowed to come to. Thank you.